This is Pre-Algebra Chapter 2.2, the distributive property. What is the distributive property? In algebra, when we use the distributive property, we are distributing the number outside the parentheses, in this case a, to each of the numbers inside the parentheses, so to b and to c. Rewriting this problem using the distributive property, we would write a times b plus a times c. These two are equivalent numerical expressions. They mean exactly the same thing. They have exactly the same value. Let's try a sample problem. You and a friend are going on a camping trip. You each buy a backpack that costs $90, and you each buy a sleeping bag that costs $60. What is the total cost of your camping equipment? I can see two possible ways to solve this particular question. First, we can find the cost of one backpack and the cost of one sleeping bag. So we could take 90 plus 60, and we could multiply that total quantity by 2, since there are two people purchasing. When we evaluate this expression, we come up with an answer of $300. Another method for finding the total cost would be to find the cost of two backpacks, so 2 times 90, and then add that to the value of two sleeping bags, 2 times $60. And again, when we evaluate this expression, we come up with an answer of $300. So our two equations here, 90 plus 60 times 2, and 2 times 90 plus 2 times 60, are equivalent numerical expressions because they have the same value. This expression shows us the distributive property because we've literally distributed our 2 first to the 90 and then to the 60. Here's another example where using the distributive property will help us to solve a problem. After touring a cave, you visit the gift shop and buy 3 geodes. Each geode costs $5.95. Using the distributive property and mental math, find the total cost of the geodes. All right, well, we know the total cost is going to equal 3 times $5.95. But there's a quick mental math way to rewrite this and make it a little bit simpler. We can rewrite it as 3 times $6 minus 5 cents. Okay? So we can use the distributive property here, 3 times 6 minus 3 times 0.05, giving us 18 minus 15 cents. For a final answer of $17.85. All right, try some of these problems on your own. Use the distributive property to evaluate the following expressions. Try these problems on your own as well. Evaluate the expressions using the distributive property and mental math. Remember, that means to round one of our numbers to a close number that's easy to work with mentally. Take whatever the remainder is and work with that using the distributive property. The next idea in our chapter is equivalent variable expressions. Two variable expressions that have the exact same value for all values of the variable are called equivalent variable expressions. You use the distributive property to write expressions such as this. Here's an example. If we begin with 3 times x plus 7, we can use the distributive property to rewrite this expression as 3 times x plus 21. These are equivalent variable expressions. Here's another example. N plus 4 times negative 2. Once again, we can use the distributive property, negative 2n minus 8, to find our equivalent variable expression. And here's a final example. Negative 5 times 2y minus 3. Using the distributive property, negative 5 times 2y will give us negative 10y plus 15. These two expressions are equivalent variable expressions. It's time to try these on your own. Use the distributive property to write an equivalent variable expression for each of the following expressions. And now we're at the final idea for this chapter, which is using the distributive property to find the area of geometric figures. So let's begin with an example of a rectangle that looks like this. It has a side length of 7 and another side length of 2x plus 5. Please excuse my strangely drawn rectangle. So to solve for the area of this rectangle, we're going to take, using area, the formula for area equals length times width. Our length is 2x plus 5. Our width is 7. Now we simply apply the distributive property to find the area, which will be 14x plus 35. We can't finish evaluating this until we learn the value of x. Let's try this same idea with area of a triangle. Here we have a triangle with a base of 12 and a height of 8 minus 3y. You'll recall the formula for the area of a triangle is area equals 1/2 of base times height. So we'll complete this problem by simply plugging in the values that we know. Area equals 1/2 of our base, 12, times our height, which is 8 minus 3y. We'll apply the distributive property to solve now. First, we'll get rid of this 1/2 by multiplying it by 12 to give us 6. So we'll have 6 times 8 minus 3y. 8 times 6 is 48. 6 times 3 is 18 times y. So the area of our triangle is 48 minus 18y square units. Now once again, we cannot totally solve until we know the value of y, but this gives us a good start. All right, there are all of our ideas for chapter 2.2. I'll see you tomorrow to practice a few of these concepts together.